Welcome to this first step in the world of robotics. Robots are all around us, from factory arms and delivery drones to tiny robots that explore the human body. But behind every robot, no matter how advanced, there's always a set of basic building blocks that make it move, think, and react. This video is designed to give you a solid foundation. You don't need to be an expert, and you don't need expensive equipment to start. What you do need is a clear understanding of how robots are powered, protected, and controlled. We'll begin by logically organizing what every robot needs: a reliable power supply, safety measures to prevent damage, and components that create motion, like motors and actuators. We'll look at how energy is managed using batteries, converters, and regulators. Then, we'll explore the wide variety of motors used in robotics, from simple DC motors to advanced servos and linear actuators. You'll also get a hands-on look at the actual components, including tips on how they're used in real-world applications. This is more than just theory. This is about seeing and understanding the real parts that make robots work. So whether you're planning to build your first robot, or just want to understand the basics before jumping in, this guide will walk you through everything step by step. Let's dive into the fundamentals and see what it takes to bring a robot to life. We need to define a power source, protection systems, motor drivers, actuators like motors or servos, and of course, a brain or microcontroller to handle commands and inputs. Batteries and protection circuits. Here we have 1865 lithium batteries mounted in holders. They are compact and offer high energy density, but they must be protected. This board is a battery protection circuit, which prevents overcurrent, low voltage, and overheating. It's critical to avoid damage or fire when using lithium cells. If your robot is stationary or connected to power, you can use an AC to DC power supply like this one. This is commonly used in lab robots or testing benches. Buck converters. To adapt different voltage levels, you can use a buck converter like this. It steps down voltage with high efficiency, useful when powering multiple devices from a higher voltage source. Small DC motors. These are basic DC brushed motors. They spin fast and are easy to control, but need a driver or H-bridge to manage direction and speed. Gearboxes. Now we see a yellow gear motor. This adds torque and reduces speed using plastic gears inside. Gearboxes are essential when you need strength rather than speed. Stepper motors. This is a stepper motor. It moves in fixed steps and is perfect for precision control in printers, CNC machines, and robotics. Standard servo motor. Here's a medium-sized servo, typically used in robotic arms or grippers. It provides position feedback and is controlled with a simple PWM signal. Micro-servo motor. This is a micro-servo, great for lightweight projects like small robots, sensors, or animatronics. Linear actuator for RC planes. Finally, this is a micro-linear actuator. It's often used in RC planes for flaps, but also works great in small robots that need push-pull movement in tight spaces. Thanks for watching. If you enjoyed this video, don't forget to like and subscribe for more Arduino and electronics content. If you'd like to support the channel, you can donate via PayPal or check out the Patreon link below for exclusive content and behind-the-scenes projects. See you in the next one. Blast off.